Assalamualaikum and a very good morning to panel of judges. I'm Rahim bin Amin, an undergraduate student from Faculty of Engineering Technology under supervision of Dr. Muhammad Almullah bin Abdullah. So today I will present my final year project proposal entitled Simulating of Geotube Structure with Trapezium Shape Under Static Loading Condition. This project is sponsored by Industrial Grant, my Flexi Tank Industri Sdn Bhd, number M039. Proceed my presentation, let me brief my content outline first. So first, an introduction will be made and it consists of objectives, scope and significance of study. Next, I will continue for literature review and methodology. Finally, as a conclusion, is my expected result. For introduction, let me introduce about the definition of geotube that I will be using in my entire proposal. So, the geotube is a container hydraulically filled with a mixture of sand and water, and the sand is transported along the inside of the tube by hydraulic pressure. And the structure of this geotube was originally shaped like a sandbag that was filled with sludge. And one of the applications is to prevent soil erosion and strengthen the structure of the soil itself. There are two companies that manufacture and develop geotube, which is Tenkate Geosynthetic Asia Sdn Bhd and my Flexi Tank Sdn Bhd. Tenkate is a multinational company that combines textile technology with chemical process technology in the development and production of functional material, modules and systems for the protection of people and their living and working environment. So, for the objective of my study are to model a trapezium shape of geotube for simulation purpose and to determine the relationship among tube size and tension stress due to hydrostatic pressure change. Next, scope of study. This study will be using SolidWorks 2020 for modeling and simulation purpose. As for the geometry, trapezium geotube will be used. Effect of tension stress and tube size will be considered, and the model is limited to standard size given by Tenkate Geosynthetic Asia Sdn Bhd, while the properties of material will be provided by MYF, which is my Flexi Tank Sdn Bhd. Next, we go to the significance of this study. So, this study aims to model a trapezium shape of geotube for simulation purpose while determining the relationship among tube size, hydrostatic pressure, and tension stress effect of geotube structure. Second one, the trapezium shape of geotube structure is still under development and require us to investigate the structure capability using simulation environment. Third one is, by conducting this study, this will be able to prove the effectiveness to determine the level of excellence of a geotube based on the shape of the build. And lastly, if this study is successfully conducted, this will contribute to a new geotube design development, which is to develop a trapezium shaped geotube and to meet the MYF design requirement. Next, we jump to literature review. There are several literature reviews that will be cited in this report. It will be categorized into 7 subchapters that are: first, geotextile geotube structure ellipse shape; next, dewatering process; third one, soil erosion; next, strength of trapezium shape; next, method of analysis; then tension stress under trapezoidal area; then hydrostatic pressure versus hydrodynamic force. The picture at the right corner is the picture of dewatering process, and the picture below the dewatering picture is soil erosion. First one, we go to the geotextile geotube structure ellipse shape. Referring to Ashish in 2015, he stated that geotube was invented with the usage of geotextile as the main material of it. Due to their excellent drainage and separation capabilities, geotextile were originally used in civil construction projects in the United States and Europe in the 1960s for road building. And Yan et al. State that in 2016, existing design approach work well for sausage-shaped tube, but they cannot be transferred straight to flat tube, which are often used in that building. And for dewatering process, referring to M. Ali Muhammadi in 2019, in comparison to sedimentation and centrifuge dewatering procedure, the use of geotextile bags for dewatering and solid management in effluent is relatively recent. Next, for soil erosion. So, Pimentel in 2016 stated that the US is losing soil at a rate 10 times faster than a natural replenishment, while China and India are losing soil at a rate 30 to 40 times faster. From Pradhan et al. In 2012, he stated that this includes measures where the sea wave in certain coastal areas could not be predicted and it affects the soil condition. And then for the strength of trapezium shape, from Utah in 2016, he stated that the triangle is the strongest form yet it is severely weakened without any of its sided. So in this study, the design of the geotube will be changed from the elliptical to a trapezoidal shape because the trapezium shape almost had the same structure as a triangle. A method of analysis in literature review from Kim et al. In 2013 state that geotube components are continually exposed to a variety of static and dynamic stresses, including wave loads, as well as lateral and overload pressure from embankment, load wake, and overlaid surface load. So, table below show the research about ground modification techniques for improved stability of geotubes for various ground waste modification. They conducting 4 cases, and the result they get is displacement and global factor for safety stability. Continue. From Das et al. In 2010 state that performance of geotextile geotube can be tested for dewatering process through the finite element method, which is FEM or FEA analysis. The test findings suggest that correct geotube and infill material selection is critical at the project location. Figure below show the relationship between water level drop and versus flow rate for dewatering process in geotube. Next, for tension stress under trapezoidal area, a study by Yan in 2016, he studied the change in pumping pressure through a fully inflated geotube affect the value of tension stress. Below is the table for the result of the study by Yan. Next, for hydrostatic pressure versus hydrodynamic forces. From Kazimierewicz in 1994, he is the first person to compute the geometrical solution based on hydrostatic pressure and design height. And from Hubaum in 2000, the equation below can be used to determine the hydrodynamic force acting on the geotube. So the below equation used to calculate the hydrodynamic force acting on the geotube. Next, I will talk about the methodology. So this project will undergo the modeling of geotube structure. After the process of problem formulation, SolidWorks 2020 will be used for simulation of parameters to seek the solution for the problem. Finally, the solution will be analyzed by graphical manner and will be discussed. The two pictures above show the sketches of trapezium geotube, and the second picture shows the position of geotube if it was a trapezium, and we pick the most stable position for the orientation of the geotube structure. This is the flowchart of methodology of the study. It consists of my two objectives of the study. So the first objective is to model a trapezium shape of geotube for simulation purpose. The second objective is to determine the relationship among tube size and tension stress due to hydrostatic pressure changes. So as we can see in the figure, it is a flowchart. So start with the literature review, then go to propose problem model, which is trapezium shape, and study about the relationship among tube size, hydrostatic pressure, and tension stress. Then we have to obtain the stress and hydrostatic pressure parameter from research paper or journal. Next, we go to the tube size investigation. Then we go to the modeling Geotube structure. Then we go to the objective 2, which is FEA simulation. Then we go to tension stress investigation. Next, hydrostatic pressure change investigation. Then after simulation successful, we go to the result. Then if the result is not satisfactory, we have to go back to the FEA simulation. Then we go through all the investigation. Then when the result is satisfactory, we have to plot the result and discussion as a graphical method. Then we have to conclude all for the conclusion, and that's the end of the flowchart. Next is my expected result. So what will be expected from this research? The result from FEA will produce von Mises stress value, displacement value, strain value, and yield strength. The analysis will determine whether all these values are increasing or decreasing. So the figure shows the example of structure undergo FEA in SolidWorks 2020 for displacement value. And next figure is a graph of stress versus strain that related to yield strength. So this is the Gantt chart for my undergraduate project 1 from week 1 to week 15. Finally, this is my planning for next semester for my final year project from week 1 to week 15. That's all from me. Thank you for listening.